I'm Brian DeLuca, and I am here with Didier Balocco at the onsemi booth at APEC, and he's going to show us some of the stuff they're doing.
Thank you. So at the top you can see what we have represent as the way we produce our silicon carbide. We start from the very beginning with the sand and the carbon that we merge together to create the boule, and then with the boule we slice the boule to make the wafer, and from the wafer we make the product, the die, and then we include the die in module or discrete. You can see here on the shelf the granulate that we have. This is the silicon carbide powder that we melt to obtain the boules. Here, this is a boule that has been cut out to be a very the same shape as a wafer.
Right.
Then we slice the wafer, and we are actually qualifying our 8-inch process for silicon carbide.
Okay.
So with silicon carbide, we can address more and more high power, and this is why onsemi, onsemi shape or range of product involved with more and more high power. And you can see here with more and more bigger package, we have started with the smallest one, like this one, the F2, or those IPM here. But we can produce, this is for motor drive, but here you see for motor drive now, we can address with EV range of even 300 kilowatt motors, and even more for trucks, buses, and so on, or tool for mining or whatever. They will need more and more power, and going for module that can cover up to the mega watt motor.
Oh, wow, okay.
So with this technology we can do. In the package you see we moved from this size that is a common size to this next size here. We have various options with this one protected for moisture and offering better lifetime. And for those bigger modules, we will now they are available either with silicon and silicon carbide, and we will continue to push those modules with much lower RDS1 for silicon carbide, but also much better module parasitics, because when it goes for very high power and very low RDS1, if you lose all the benefit in the packaging, it doesn't make sense.
I gotcha. And these are for industrial, these?
We have here for industrial, and here we have for automotive application.
Okay.
So we cover both markets. Silicon carbide is at the beginning designed to be automotive and industrial qualified.
Okay.
So when we do the design, it passes both qualification.
Gotcha.
The only difference is the manufacturing plant. One is automotive, one is industrial.
Okay.
That's all.
So now, what do engineers need to know when they integrate this into a system? Like, what's the biggest thing they need to think about, whether it's automotive or industrial?
What do
they need to think about in their design when they're designing this into a system?
What they need to think is mainly what they need to maybe be more confident with is our reliability and the capacity to use in an efficient way.
Okay.
For reliability, the fact that we control the full chain.
Okay, from start to finish, yeah.
We have a method in place where we control each steps and so on, and we do very hard tests, and we go above the standard of JEDEC that say to test silicon carbide you can use 100 volt. We go for the full rating voltage, so if it's a 1200 volt device, we will test with 1200 volt and not with the JEDEC standard to place our customer in a confidence zone. Then comes what I can get out of those parts.
Okay.
And this is why we have put in place a complete ecosystem, simulation system, where the customer can select the topology he wants to simulate, select our part, change the environment, and see the result in a very fast manner.
And you guys are providing the tools for them to test?
Yeah, the tool is completely free, online. You just need a My Own account to log in.
Okay.
And then you can test all our technology inside onsemi. So you can compare, for example, IGBT versus silicon carbide, see what is the difference, because as we produce IGBT, we can include the IGBT in the tool. We have also the low voltage and medium voltage MOSFET. We are the only one to offer that, because we have those. And when you make a AC/DC power supply, at the end you have a low voltage.
Right.
So you need to see how those will operate when you mix the technology. So do the simulator. It can mix the technology. We have motor control part also for traction EV or for motor control. And now we have introduced our new SPM31, this package here with silicon carbide. And what people do not realize that for the moment, people in motor control think that motors will be IGBTs.
Right.
We in onsemi think motor control in the next future will be silicon carbide.
Gotcha.
And we are ready for that. And we can prove that with silicon carbide, we can reduce the size of the heatsink for the same motor by a factor of more than 10.
Wow, okay.
So you imagine the saving in losses,
Yes.
and so the saving in dollar when you operate the motor in the field. You save dollar by moving to silicon carbide. You save space, you save heat, you save dollar because your energy bill decrease, and you save CO2. That is also one of the trends with onsemi to go for a more greener world.
Well, Didier, thank you for showing me what you guys are doing at onsemi. It was a pleasure
Thank you.
meeting you.
Nice to meet you too. Thank you.